This last video in the series, what we're going to do is we're just going to verify a few identities by using our half angle formulas. So we have this cosquare of theta over 2 is equal to secant theta plus 1 divided by 2 secants of theta. All right, so first thing we do is let's go ahead and just square the identity for cosquare of theta over 2. Right? Now remember, the identity for cos of theta over 2 is 1 plus cos of theta divided by 2, right? And what we're going to do is we're going to square that. And so what that does is that it just cancels out the plus or minus, because whenever we square either a positive or negative number, it just goes positive. It also cancels out the square root. And so we're left with 1 plus the cos of theta divided by 2. Now, the sneaky part with this one is that you notice there's a secant in the denominator, okay? And so what I'm going to do is I'm going to multiply the top and the bottom by secant of theta. All right. And so what that means, so I'm going to have to distribute the secant in the numerator, and then the secant in the denominator is multiplied by the 2. And so this ends up being sec of theta plus cos theta sec theta divided by 2 sec of theta, right? If we look at what we have, we certainly have the sec theta. We have the 2 secants of theta. Recall that secant is the reciprocal of cosine. So we have our sec of theta plus cos theta times 1 over cos theta divided by 2 secant of theta. And so finally, that just means that these are going to cancel out these cosines of theta, and we will be left with what I believe we need, sec of theta plus 1 divided by 2 secants of theta. All right, so not too bad of a proof. The tricky part is just knowing that you have to multiply and divide by secant of theta, right? And that happens a lot in mathematics, where we just have to pull something out of nowhere and just kind of engineer that for ourselves, okay? So, and the hint is to maybe look at the denominator and kind of see that, okay, well, I need a secant there, so the only way I can do that is to multiply the top and the bottom to get to a secant. In a similar fashion, we have the tan of theta over 2 is equal to 1 over cosecant theta plus cotangent theta. All right, so remember that there are two formulas for the tangent of theta. Okay, so remember there is sine of theta divided by 1 plus the cos of theta. Or there's another one where we had 1 minus cos of theta divided by sine of theta. Okay, the one we are going to use is probably going to be this one, just because if we look, we have one term in the numerator and two terms in the denominator. All right, now here's the trick that I think about with this one. Okay, similar to what we did before, we have to multiply and divide by something magical. All right, and I want you to notice that we have a cosecant here and there's a 1 here. All right, so it probably begs us to at least try to multiply by cosecant theta divided by cosecant of theta. Okay? Now, if I distribute in the denominator, okay, by the way, this should work out really nicely, just to let you know. We're going to end up with sine of theta, cosecant theta in the denominator, plus cos theta cosecant theta. All right. Now, of course, we know that cosecant is the same thing as 1 over sine. So this could be equal to sine of theta times 1 over sine theta divided by, I'm just going to leave this one as is because that looks good. I don't want to take the reciprocal of that one, plus cos theta times 1 over sine theta. The signs cancel out. We're left with 1. So we get 1 over cosecant theta. And then we could just write this as cos theta divided by sine theta. And it just so happens that this is the ratio identity for the cotangent. So this is going to be equal to 1 over cosecant theta plus cotangent theta, which I believe is what we were asked to prove. Okay, good. All right, so we're all done with this half angle business. Okay, so this was a pretty deep section because we took a look at, um, first of all, our double angle formulas, then our power reducing formulas, and then finally our half angle formulas. So it might be helpful to go back through this section because there's a lot in it. And again, what might also be helpful is to start making your own formula sheet. Okay, so what I do is I just cut and paste these into a Word document. Okay, and I just have my own. You could probably cut these from the notes so that way you have them to be able to make up your own. Okay. All right, so we have one more set of formulas to go through, and that's going to be in the next section where we look at product to sum and sum to product formulas. Okay, and that's going to be everything for our trigonometric formulas.